The mass of the car is 2,300 kilogram. For time t is equals to 0 to 5 seconds, determine the acceleration. So for first 5 seconds, because it is a straight line, because it is a straight line, so you can use either a formula or you can use a gradient. You will get the same answer. The final speed, so the final speed is 15. The initial starting speed is 0 and the time interval is 5. And to calculate the acceleration is v minus u over t. So we can use this equation. So v minus u over t, v is the final speed, that is 15. Initial speed is 0 and the time interval is 5. So that is equals to 3 meter per second square. Or you can find the gradient y2 minus y1 over x2 minus x1. You will also get the same answer. Gradient is valid by like using a gradient method from speed time graph. It is valid for any type of graph, even it's a straight line or a curve. For a curve, you will draw a tangent, but for a straight line, you will take any 2 points and find the gradient. So acceleration is 3. The resultant force on the car, so if the acceleration is 3 meter per second square, you need a resultant force. The formula which we will use to calculate the resultant force, that force is equals to mass multiplied by acceleration, or F is equals to ma. The mass is 2,300 and acceleration is given 3. So it will be equal to 6,900 Newton. The next part, describe the motion of a car between t is equals to 10 second to 15 second and explain how figure 1.1 shows this. So figure 1.1, basically a speed time graph. What slope represents? The term slope, it represents the acceleration. So here for like first 6 or 7 seconds, the acceleration slope is constant at this point. Here what happened, the slope is decreasing, and at this point the slope is equals to 0. If slope is 0, acceleration is also 0. So what we have to do in the question, from 15 seconds, from 10 second to 15 second. So from 10 to 15, what is happening? The slope is decreasing. If the slope is decreasing, it means the acceleration is also decreasing. And if acceleration is decreasing, you can also say about the resultant force, that the resultant force is also the car motion between 10 to 15. Its acceleration is decreasing as the slope is decreasing with a speed increase. Then between 10 second to 15 second, the force exerted on the car due to the engine remain constant. Suggest and explain why the car moves in this way. So from 10 second to 15 second, the force exerted by the engine is constant. If the force exerted by the engine is constant, basically what is happening, as it is accelerating, so speed is increasing, so air resistance is also increasing. Like if I say the force of the engine is say 100 Newton and the speed of the car at this point was 2 meter per second, then because there is a resultant force, whenever there is a resultant force, there is acceleration, so speed will change. So as the speed change, now example, if the speed is 5 meter per second, so when we compare the force, the air resistance, it will be different. When the object is moving slower, the air resistance, smaller air resistance will act, maybe 10 Newton is there. But as a moving at a higher speed, the air resistance will also increase. So maybe here the air resistance is 30 Newton. So as what happened, even though the force from the engine is constant, but because the car speed is changing, speed is increasing, that's why the air resistance increase. And as the air resistance increase, what happened to resultant force on the car? The resultant force will decrease. You can see in this one the resultant force will be 90 newtons, but the other case the resultant force is 70 newton. So due to air resistance, the friction between the car and the air particles increases, so that reduces the acceleration. How it reduces the acceleration? Because the driving force is not changing, the force which is opposing the motion, that is increasing. That's why the resultant force will decrease. Question 2a. State two properties of an object that may be changed by action of the force. There are different effects. Force can change the shape, the size, the direction of the motion, the speed of an object. So you just have to mention two of them. It can change the shape or direction of the motion. It can change the shape or the velocity, the speed at which the object is moving. The state here means if an object is at rest, it will make it move. Basically, one you will write shape and another one direction or velocity. Next part, a chest expander is a piece of equipment used by the athletes in a gym. Figure 2.1 shows a chest expander that consists of 5 identical springs connected in parallel between the handle. Each spring has an unstretched length of 0.63. Two athletes are stretching the chest expander by pulling one of the two handles in opposite direction. The spring obeys Hooke's law. What is meant by this statement that it obeys the Hooke's law? Force and extension are directly proportional within elastic limits or within limit of proportionality. Each athlete pulls the handle towards himself by a force of 1300 Newton. State the tension in each spring. When we apply a force by using a wire, by using a string, what we call that as tension. So there are 5 springs, total force is 1300, and there are 5 springs, so 1300 divided by 5, so force on each spring will be 260 Newton. The total force on the handle, as you can see, the total force on the handle is 1300. So each spring will experience a force because that will be divided between the 5 springs. So each spring will experience a force of 260 newtons. The chest expander stretches and each spring now is 0.94 meter long. Calculate the spring constant. Original length was 0.63, new length is 0.94. So to calculate a spring constant, F is equals to KE, or K is equals to F divided by E, or F divided by X you can use. So force on each spring is 260 and the extension The change in the length, originally it was 0.63, now it is 0.94, so the difference will be there. The final answer is how much? The three significant figure, 839 Newton, you can write, Newton per meter, which is about 840. So 839 Newton per meter. Because it is K, so unit of force is Newton and unit of extension is SI unit is here, extension is in meter, so it is Newton per meter. The next question, state the energy changes that take place as the two athletes use their muscles to stretch the chest expander. What is the energy transformation or energy change? Chemical, first they are using their energy, chemical energy change to kinetic, and then when something deformed, changes its shape, size or length, then it will have elastic strain energy. The elastic strain energy will be there. Question 3. Figure 3.1 shows a shooting competition where air rifles fire soft metal pellet at a distant target. When an air rifle is uh, when an air rifle is fired, it exerts an impulse. Impulse means a change in momentum of 0.019 on the pellet. Define the term impulse. The meaning of or definition of impulse. Force acting on a body to produce a limited change in momentum or change in momentum. This is known as the definition of impulse, or the product of force and time, also known as impulse. The next part, the pellet has a mass of 1.1 exponent minus 4 kilogram. Determine the speed at which the pellet leaves the rifle. So in the beginning, because the pellet will be stationary and then it will move. So we know the impulse is equals to the change in momentum, F into T, as well as mv minus mu. So impulse is 0.019. The mass of the pellet is given. The initial velocity is 0. So if initial velocity is 0, this whole factor will be removed. So I can say it will be m into v. And what is m? M is 1.1 into 10 to the power minus 14. So v will be equal to impulse divided by mass. So what's the final answer for the speed? 173 meter per second. That is the speed at which this pellet will come out. The kinetic energy of a pellet as it leaves the rifle. So kinetic energy is half mv square, 0.5 mv square. The mass is given, which is 1.1 exponent minus 4, and the speed already you calculated in the previous part, which was 173 meter per second. When you substitute the values, you will get the answer as 1.63 joules. A pellet melts when it strikes the target. Describe how the molecular structure of a liquid metal differ from a solid metal. So when the pellet strikes the target, it melts. So how their structures are different from each other. So in a solid, what we will have a regular arrangement of the particles, and particles have fixed position. They can only vibrate within the structure. Where in liquid, the particles, there is no regular arrangement of the particles. Particle can move around each other. Even in liquid, the vibration is there. Vibration can occur, but not vibration about the fixed position. Like example, if I have a liquid like water, molecules are there. So these water molecules are vibrating and they are moving around each other. So vibration is there between the particle. Particles are not having a fixed position, they vibrate. Do not vibrate about fixed position. You don't. So solid, they have a regular arrangement, strong forces there. Next question. Figure 4.1 shows a loudspeaker that is producing a sound wave in air with a frequency of 15,000 hertz. A hollow paper cone is there. Describe how a cone of a loudspeaker produces a sound, and it's of 3 marks. So basically, how the sound waves are produced, it is produced by vibration. Here the cone is there, so cone will vibrate. It will disturb the air molecules and produce compression and rarefaction. And they give you the frequency, as they mention the frequency, so you can use this frequency like vibrate. They will vibrate with a frequency of 15,000 hertz. So by vibration of cone, as air particle vibrate, it passes and produce compression and rarefaction. And you can refer this vibration, and as well as the type of the wave you can also mention. So these are some sample answers as you typed in the chat. The speed of the sound is in air is 330. What is the wavelength? So the frequency already they mentioned, that is 1500. Sorry, 15,000, not 1500. 15,000 hertz. So you have the speed, you have the frequency. So you need a wavelength which is equals to V divided by F. So 330 divided by 15,000. What's the final answer for the wavelength? 0.022. So when you substitute the values, you will get 0.22, 0.022 meters. The next question, the loudspeaker is placed a considerable distance to the left of the barrier with a gap. The width of the gap is double the wavelength. Sound from a loudspeaker reaches the barrier and passes through the gap. Figure 4.1 shows a gap. On figure 4.2, sketch a diagram that represents the sound waves as a series of wavefront traveling towards the left of barrier in the gap and away from the barrier. So as they mention in the question that the wavelength, the gap is approximately twice of the wavelength. So if this was, like example, 5 centimeter or 4 centimeter, then the wavelength should be 2 centimeter. And it will have a less diffraction. How you represent a small diffraction? Only the edges will bend, but the wavelength, you should keep the wavelength same, because if the medium does not change, the wavelength is remain unchanged. So it is diffraction, less diffraction rather than refraction. Refraction means when the wave travels from one medium to another, but when the wave is passing through the gap, the slit, edges, we call that as diffraction. The wavelength dimension, the loudspeaker is placed at a to the left, and the width of a gap is double the wavelength. So means the distance between the two successive compressions or rarefaction. So when the wave is passing through, we want to draw wave which is traveling towards the barrier, wave which is in the gap, and then which is traveling out. So wave which is traveling in the gap, and the wave which is traveling out from the gap. And as you can see, the wavelength, when the wavelength is larger than the gap size, then it will have a small diffraction. Is it clear? The next question, figure 5.1 shows a sphere that is negatively charged. The sphere is attached to a plastic stand. On a figure, draw an arrow to indicate the pattern and the direction of electric field. So you can use a screen annotation to complete this electric field. Yeah, that's right. Because it's a negative charge, so electric field lines are pointing into. The next part, a small uncharged metal sphere S is suspended by a plastic thread, and it is brought near to close to a negatively charged sphere. On figure 5.2 shows two spheres. By drawing on figure 5.2, indicate the distribution of the charge in S. You can use a screen annotation to show distribution. So one side it will be positive and the other side it will be negative. But keep in mind the number of the positive and negative charges should be same. Like if you draw two positive on the left, it should be two negative on the right. The next part, state what happened to S. So basically what happened to S, it will attract or move towards attracted towards the sphere or move towards the sphere. The charged sphere, and the earth wire is then touched against S. Describe what happened. So now what happened? There was a distribution of the charge, positive one side, negative other. We connect an earthing wire. What will happen? So this earthing wire will remove the electron, the negative charge, the electron, so it will become overall positively charged. Because the like charges repel, electrons in the S are forced to come out and they will move out through the earthing wire. The metal sphere S is an electrical conductor. The plastic thread is an insulator. What is the difference? Explain the difference by referring the structure of the two material. Like why the wire, it's a conductor, and why the thread is insulator. Because there are free or delocalized electron. So as there are free or delocalized electron in the metal, metal is having electrons, so that's why it can conduct electricity and allow the charges to move through. Why in plastic the electrons are not able to move? Because the plastic, the type of the bonding, it's having a covalent bonding in which there is a sharing of electron. Like two atoms are there, two molecules are there, uh, different atoms in a structure. They have a sharing of electrons. So when they have a shared electron, these electrons are not free to move around in the structure. But in a metal, what happens? There's a positive ion and it loses electrons. So this delocalized electron can move within the structure. Figure 6.1 shows a shower that takes in cold water. The water passes through an electric water heater and then emerges from the shower head at a high temperature. The power of the heater is 9,000 watts and the shower is powered by a 230-volt supply. Calculate the current. So P is equals to VI or P is equals to IV. So we can find the current, which will come out 39.1 or rounded off to 39 ampere. Suggest a suitable rating for the fuse in the heater. Like the maximum, the current which is passing through this is 39 ampere. So what fuse we should select? A fuse rating, it should be a bit more than what is allowed. Like you can select 40 ampere, 45 ampere. Because slight fluctuation can happen, the slight change in the current can happen. It should not blow the fuse. For example, if it is 39, you can select 40, but practically it is a bit more than what is required, because small fluctuation is the device or the appliance can tolerate, but if it's a large fluctuation in the current, it cannot be tolerated. Because the current in the device is 39 ampere, so we should select a fuse more than that. Fuse, the purpose of the fuse is to protect the device. Like example, otherwise if too much current is there, that will damage the device. To protect the device from too high current, we are using a fuse, example a 45 ampere fuse. So if a current is 45 ampere, it will blow. If it is less than that, the device will work normally. So for safety of the device, we use fuse in the circuit. The specific heat capacity of the water is 4200. The initial temperature of a cold water is 16. Determine the maximum mass of a water that could be heated to 35 degree in 1 second. So you already know the power. Using the energy is power multiplied by time, so you can find the energy, and E is equals to Cm delta T. Energy is power multiplied by time, so you can find first energy, and E is equals to Cm delta T. You have delta T, you have specific heat, you have E. So you can find how much mass of the water can be heated. So energy power multiplied by time, power is 9000, time is 1 second. So when time is 1 second, energy and power have the same value. Then specific heat capacity is energy divided E is equals to Cm delta T, or C is equals to E divided by M delta T. So you can use this value, substitute specific heat, the value for the change in temperature, the value for energy. You can find what mass is 0.0113 or 0.113 kilogram will be the final answer. A safety control in the shower: switch off the shower when the water becomes dangerously hot. The control uses a thermometer to measure a temperature of the heated water. Describe a structure of a thermocouple. Include a diagram in your answer. So draw a thermocouple. You can use a screen annotation to draw. And when you draw, it should be labeled a millivoltmeter and two wires which are coming out from the voltmeter, made up of same material, and the wire which is connecting the two ends, that is made up of different material. One we call hot junction, another one we call cold junction. And describe the structure. So basically you have to describe the structure, that two different metal wires which are joining the voltmeter. Yeah, so that's right. And then suggest copper and iron here. Then suggest one reason why the thermocouple is suitable for this purpose. Basically the advantage of the thermocouple, and you don't have to draw these arrows, you don't have to show the direction of the movement of the particle. So it is responsive. In a short time it can record a temperature change. Rapidly, reason why you will not find high temperature as an option here, even though measuring a high temperature is advantage of thermocouple, but the thing is here you will have a water, so maximum change in temperature, like rise or maximum temperature, will be 100, or if it was a impure water then it will be a bit more than 100. That's why can measure high temperature with reference to the question is not correct. It is right, that's an advantage, but with reference to question, it should be like it can react responsive, quick acting, measure in a short time the temperature change. So I'll share another link and continue this discussion, because the next question will not be able to finish within 3 minutes.